Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, petrochemical fired heater. Now what is that? When producing petrochemicals, two different kind of cracking are common. Fluid catalytic cracking for petroleum fraction and steam cracking for natural gas liquid. The process frequently include use of extreme temperature and pressure. Fire heater are well equipped handle the condition by offering superior temperature, uniformity and process control. The fired heater capability include up to 70 MMBTU per hour greater in some of application, efficiency 95%, process temperature 1700 degree Fahrenheit, process pressure 3000 psi, carbon steel, low and high alloy metallurgical available, gas, oil and dual fire design, cabin and circular design, turn down ratio up to 14:1. Now petrochemical fire heater applications. Understand safety, reliability and durability. Fire heater is necessary. Company working petrochemical ensure safety of their employee, public and environment. Each of petrochemical fired heater are custom sized, built, meet specific customer application or flexibility, attention, detail. Each of the ideal system of their need. Some of the specific applications are heat transfer fluid, chemical and various specialty process fluid, regeneration gases, air heating applications, crude oil and emulsion, vaporizer, natural gas, research and development process. Now, heat transfer fluid, heater application and specification. Now, long history making safe and reliable heat transfer fluid heater, it is necessary provide a pump skid for use the thermal fluid heater, pump skid and single pump with one or more installed spare are available. Typical applications are chemical reactor, resin kettle, evaporator, heat setting, dehydrator, drying oven, paint, furnaces, dye, asphalt, extruder, roll, pilot plant, offshore and gas processing. Technical specification 0.1 to 70 million metric British thermal unit per hour means MMBTU per hour, efficiency 95%, process temperature 750 degree Fahrenheit, thermal fluid pressure near atmospheric, forced circulation, gas, oil and dual fire design, vertical, horizontal design, turn down ratio up to 14:1. Regeneration gas heater. Convective heat transfer design, regeneration gas heater are ideal. Gently heating regeneration gas and sending wet desiccant towel dry out the desiccant. Regeneration has heater operate temperature 450 degree Fahrenheit to 650 degree Fahrenheit, pressure up to 1100 psi. Localized area, elevated temperature, heat transfer coil, higher operating pressure, resulted tube failure, natural gas flowing from the production well and underground storage required dehydration to protect distribution system for corrosion and hydrate formation. Commonly used solid desiccant absorption, dehydration process, wet gas flow, pressure vessel, tower filled with solid desiccant. The moisture absorbed on the surface desiccant. Gas leaves the tower dry and desiccant is saturated. Moisture, gas flow is switched to another tower having dry desiccant. Now, regeneration gas heater overcome problem occur. Type of fired heater. It is reliably operate critical process because high velocity, salt flame burner and convection heat transfer design eliminate the potential hot spot on tube. Very uniform tube wall temperature are result unique design. Over here, dozens of safe, long-lasting and reliable regeneration gas heaters have supplied customers for solid desiccant absorption dehydration process plant. Now, convection heat transfer resulting low heat transfer flux rate, predictable tube wall temperature without hot spot, salt flame burner prevent tube flame impingement, lower pressure drop, close temperature control, rapid response, heat load requirement, a forced draft, burner prevent flashback, and hazardous area control. Now, industrial furnace is a device used to produce heat industrial process, typical operating temperature 400 degrees Celsius. The furnace generates by combustion fuel with air and oxygen or electric energy. They are used across various industries, application, chemical reaction, cremation, oil refining, and glasswork. Residue heat is expelled fuel gas. 5. Industrial furnace encompasses wide range, high temperature equipment, specific type, direct fired heater. Also, direct fired furnace and process furnace, direct fired heater are primary use, refinery, petrochemical application, efficient transfer, heat to process fluid by means combustion. Now, industrial furnace, metallurgy, and batch oven, direct fired heater are optimized, precise temperature control, high thermal efficiency, hydrocarbon processing. Industrial furnace are designed according international standard. Some of the most common ISO 13705 petroleum and natural gas industries, fired heater, generate refinery service, American Petroleum Institute, and standard 560 fired heater for general refinery services. Fuel flow in the burner and it is burnt into air provided from air blower. There are some more burners in a particular furnace which can arrange in cell which heat particular set of tube. Burner can be floor mounted, wall mounted, roof mounted depending on design. The flame heat up the tube which is turned heat the fluid inside first part of furnace known as radiant traction firebox. The chamber where combustion takes place. Heat is transferred, mainly radiation, to tube around the fire in the chamber. Now fluid heated pass through tube and those heated a desired temperature gas from the combustion are known flue gas. After the flue gas leave the firebox, most furnace design include convection section. Here, heat is recovered from venting to atmosphere flue gas tank. HTF means heat transfer fluid. Industries also use furnace to heat secondary fluid. The specific additive, anti-rust, high heat transfer efficiency, those heated fluid circulated whole plant heat exchanger to be used whenever heat is needed. Instant directly heating the product line, product of material may volatile and prone cracking the furnace temperature. In radiation section, where tube receive almost all heat radiate from the flame, vertical cylindrical furnace, tube are vertical, tubes can vertical or horizontal, placed along refractory wall, the middle etc. or arranged in cell. Stirred are used to hold insulation together and wall of the furnace. They are placed 300 mm apart inside the furnace. Now, the tube which are reddish brown and corrosion carbon steel tube and run the height of the radiate section. Tube are distance away from the insulation so radiation can reflect it back of the tube. Maintain a uniform tube wall temperature. Tube guide at top, middle and bottom hold the tube in place. Convection section are located above the radiation section. When it is cooler, to recover additional heat, heat transfer takes place by the convection. Tube are fin to increase its heat transfer. First three, tube row, bottom of the convection section. Radiation section is the area where tube without fins are known sealed section. Shock tube, the name because they still expose plenty radiation firebox and they also shield the convection section tube. They are normally less resistance material, high temperature in the firebox. Area, radiation section just before flue gas enter the sealed section into the convection section called breach zone. A crossover tube and connect from the convection section outlet, radiation section inlet, crossover piping normally located outside so temperature can monitor and the efficiency of the convection section can calculate it. Slide class. Top allow personnel see the flame set and pattern from above. Visual inspect flame impingement is occurring. Flame impingement help when flame touches tube and causes small isolate spot at very high temperature. Radiation coil. Series of tube and horizontal vertical hairpin type connected at end. 180 band. Helical in construction. Radiant coil absorb heat the radiation. The single pass, multi-pass, depending process side pressure drop. Radiant coil and bend are radiant box. Radiant coil material are the carbon steel, low temperature surface, high alloy steel, high temperature surface. They are supported, radiant side wall, hanging, radiant roof, material of support, high alloy steel, design radiation coil, care taken to provision expansion, hot condition kept. Burner. Burner in vertical, cylindrical furnace are located floor. Fire upward. Some of the furnace have side fire burner such as the locomotive burner type made high temperature refractory and flame contained. Air register located below the burner and outside air blower device movable flame and when the control shape and pattern of the flame where it is spread out even spiral around. Flame should not spread about too much will cause flame impingement. Air register classify primary, secondary and applicable tertiary depending when air is introduced. Primary air register is responsible supplying the primary air the burn, which are first introduced combustion process, air essential, initial ignition and fuel combustion. Secondary air is add primary air, supplement combustion, helping to achieve more complete burning, improve efficiency by ensuring all fuel burn thoroughly. Burner include premixer, which combine air and fuel before they enter the burner. Mixing is crucible, ensuring uniform mixer, which enhance combustion efficiency, reduce emission, and some advanced burner even steam premix to preheat the air and create better mixing of the fuel and heated air. Steam not only add mixing but also contribute maintain stable flame condition, especially high capacity combustion system. Where furnace design, floor is typical made different material, the furnace wall. Floor is usually constructed from hard catastable refractory material which are designed withstand high temperature. Furnace provide durability. This type refractory material not only heat resistance, also allow technicians to safely walk it during maintenance activity without causing damage the surface. Furthermore, refractory material are chosen of ability maintain structure integrity over time even under intense thermal cycling, chemical stress, typical industrial combustion process. A furnace lit by small pilot flame in some older model by hand. Most pilot flame nowadays lit by ignition transformer, much like spark plug pilot flame in the lit up main flame. pilot flame use natural gas when main flame can cause both diesel and natural gas. When using liquid fuel, atomizer is used. Otherwise, liquid fuel will simply pour into furnace floor and become hazard using pilot flame, igniting and lighting the furnace. Safety easy compared using manual ignition method like soot blower. Soot blower are found convection section as the section above the radiant section. Air movement is slower because of fins. Soot tend to accumulate here. Soot blowing normally done, efficiency of the convection section decrease. When it can calculate looking the temperature change, crossover piping and convection section axis. Soot blower are flowing media such as water, air, steam and remove deposit from the tube. This is typically done during maintenance, which air blower turn on. The several different type of soot blower use wall blower of the rotary type mounted on furnace wall and pretending between the convection tube and lenses are connected steam sources, hole drilled at interval along length. When it turn on, it rotate ball and shoot off the tube out through the stack. Flue gas stack is the cylindrical structure top of the heat transfer chamber. The directly blow it, collect and flue gas bring it up high into atmosphere when it will not endanger person. Stack damper contain walk like butterfly. Regulate draft pressure between air intake and air exit furnace, which is what cool flue gas convection section. Stack damper regulate heat lost the stack. The damper close amount of heat escaping furnace. Stack decreases, but the pressure of the draft in the furnace increases, which poses risk working around there air leakage in the furnace. Flame can escape out, firebox, even explode in the pressure is too great. Insulation. Insulation is important part furnace because it improve efficiency by minimize heat escape from the heater chamber. Refractory material, fire bricks, catastable refractory are ceramic fiber used to insulation. The floor of furnace is normally catastable type refractory, while wall are nailed and guided piece. The ceramic fiber commonly used roof, wall, furnace and typical density. The maximum temperature rating 2300 degree Fahrenheit, 8 pound per feet cube. Density maximum temperature rating are 2300 degree Fahrenheit. Actual service temperature ceramic fiber bit lower the maximum rated temperature. Foundation. The concrete pillar are foundation which heater is mounted. They can 4 number heater may 24 number for large size heater. Design pillar entire foundation based on load bearing capacity, soil and seismic condition prevailing area. Foundation bolt are grounded foundation after installation of heater. Exhaust door. Heater body provided exhaust door various location. Exhaust door used during shutdown heater. Normal size of exhaust door 600 into 400 mm with sufficient movement of people, material in and out of heater during operation. Exhaust door properly bolted using leak proof high temperature gasket. Okay guys, this is up to our today's topic, petrochemical fire heater. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.